Good morning, everybody. How you guys doing? Um, Let me kind of get set up here. Little bit running behind. Didn't set up the YouTube chat bubble stuff just yet. Excuse me. Close that down. Move this over. Anyway. How you doing there, Paul Orchard, Trail Dust, Robert Lonis, Mick Chu, Transcendental Artist Studios. What's up, Saul Burt? Ben Strickland, been a while. Coffee. Yeah, I'm still head foggy. I'm still drinking my coffee. But don't worry, I have my tea set up right after that. Alrighty. Where we at? What we doing? Let me pause this. Alright. Morning. I think it's going to be in the 80s here today. I think we're hitting 60s today here. Donut, how you doing, man?
Morning.
I'm wearing one of my Christmas gifts. I don't really have space to stand up and back up and show you guys, but I mean, I got a kilt.
Somebody got the battle skirt for Christmas.
Battle skirt! There you go. I'm getting harassed on Facebook. So yeah, Merry Christmas or after Christmas. Merry after Christmas? Is that belated Merry Christmas? Happy holidays and New Year coming up. Can't come soon enough, man. I tell you that. That's what she said. Now, I don't know how time-wise how you guys have, but I do know that we have a topic today that will probably go long.
And I've got about 1 extra hour that so that's
cool.
I can go long. So
and everybody knows that
we're doing our Christmas dinner stuff at noon today. So
okay, and everybody knows that Adam over at Speargrass Forge is my doppelganger. So it's like if I have the time, he's got the time.
I got plenty of time tonight.
Told you. What's up, Dogbone? What up, Aimless? What up, Mountain Home Forge? Eric, Jake, good morning. Apparently my sinuses are exploding and I've got a bloody nose. Jeff Kren, good morning. What's up, everybody? Yes, I hope everybody had a great Christmas. I scrolling through Facebook, I saw everybody posting, look what I got, and I'm over here going, yeah. Christmas is a great time for new blacksmiths to be, getting their new tools and everything, and it's wonderful to see every Christmas, every holiday. Morning, Boar. But yeah, the topic today, if you can't read, I can't even point, is rebar, or as it's called not in America, reinforcement bar. Yeah, so reason I really wanted to do this as a topic, and reason it was pushed back until Speargrass could be here for it, because he knows a lot about it. And Sully knows a lot about it. Cause Sully, don't you use it in your business, your line of work as well, or is it just ground rods you use? No. Okay.
No.
I thought you did for something. No.
Nope. I don't. I the only thing I've ever done with rebar in my entire life is bend some edges over and made some stakes to hold down a tarp on the grass. Kind of like doing a homemade slip and slide kind of thing.
Yeah. Morning, Bloobs. Yeah. Slip and slide with rebar. Sounds like a fun ride.
No, the rebar was the stakes. Come on now.
I know. Still. Uh, but yeah,
It's not like I threw. It's not like I threw all the leftovers out on the middle of the tarp and said, "All right, go, kids."
Bill Corey, how do? But yeah, like I said, one reason I really wanted to discuss it is because in the blacksmith shop, rebar it's one of those first steels people can get. You know, like they go, even like fresh green beginners. They go, I got a bunch of rebar scrap from a project I did. You know, a couple years ago, a couple months ago, or that I've scrounged, thinking, oh, rebar's cool. And then they put it in the forge and they hit it with a hammer, and I'm blacksmithing. Yes, you is. Morning, donut. Wait,
Hey.
I said that.
And, you know, and like I said, I don't know a whole lot about the subject. I mean, I'm sure everybody else is a little bit more learned on this than I am. But I mean, like I've seen some really nice artwork done out of rebar that I mean, you kind of step back and you're like, what? Wait, really?
Yeah. It
Neat idea.
brings up my favorite point about rebar, and I'm gonna say that before I let you and Speargrass, you and Adam, just explode with your fountains of knowledge. You know, explode like, you know, December 1st after, you know, N. Morning, Shane. If you'll pardon the crass analogy there. When you guys get it, you'll get it. Yeah. One big argument that everybody says about rebar is, oh, you know, it's a hot dog steel. It's you know, not a good steel. It's not a good, you know, it doesn't harden. It doesn't this. It doesn't do that. It doesn't do. So what? If you're not making a knife or a tool, that doesn't matter. If somebody's asking about the, you know, can I forge this with rebar, and your immediate answer is no, because it doesn't harden, you just told me that you're a bladesmith without telling me that you're a bladesmith. You know, not everything needs to become a blade. Okay? Morning, Curtis. Chewy. Hubcap. So yeah, with that out of the way from me, rebar, like Selbert said, makes beautiful pieces. It makes beautiful pieces. So yeah. And as for addressing the hot dog steel and how it's not a good steel and this and that, I could tell you till I'm blue in the face, you know, that's not entirely 100% true. Excuse me, just choked myself. But we have some science to back it up and explanations of why people think it's a crappy steel. So take it away, science boys.
Alrighty, well, I'll take over because I'm.
Yeah.
So, for those of you that
Science peoples.
can only hear my voice, I'm Adam from Speargrass Forge. So I used to work in steel reinforcement. I used to work in steel reinforcement manufacturing, and also so we supplied a lot of the you know, large projects and general contractors and stuff like that. So to start off with, when talking about hot dog steel, just like any found steel, like any scrap, it depends on where it comes from. There's 4 classifications of reinforcement bar, generally speaking. There's a lot more sub-classifications, but there's 4 classifications. So there's general purpose, high carbon, general purpose reinforcement steel, high carbon reinforcement steel, what is sometimes known as European reinforcement or pool bar, and then there's stainless steel. So what I'm going to start off with first is general purpose. So general purpose reinforcement bar is like general purpose concrete. It is used for driveways, sometimes like, you know, foundations in houses, sometimes walls in houses, you know, footpaths, that sort of back patios, that sort of things. Sometimes going inside post holes for fencing, sometimes retaining walls, small retaining walls, etc. Like general purpose concrete, it is the lowest quality of reinforcement that is available. Now, on a metallurgical standpoint, right, it contains between 0.19 and 0.35% carbon. It contains between 0.1 and 0.34% silicon, 0.03 and 0.07 sulfur, 0.01 and 0.03% phosphorus, 0.036 and 1.34 manganese, and of course 97 to 98% iron. So they're the main components of your general purpose reinforcement steel. Now, if you compare that to, so for example, a knife steel like 1084, one that I just pulled up for example, that has a carbon content of 0.8 to 0.93%, a sulfur content of 0.04. So that's right in the middle of the sulfur content for reinforcement bar. A phosphorus content of 0.05, which is higher than reinforcement bar, and a manganese content of 0.06 to 0.009%. So that's, of course, again, right in the middle of that manganese content for reinforcement bar. But that, now, again, that is the lowest grade general purpose reinforcement. Now, or having said that, coming from a reinforcement background where I worked in reinforcement, a lot of our projects were bridges, apartment buildings, 3-4 story apartment buildings plus, roads, industrial areas and stuff like that. Now, in construction of those, they need to have a stronger type of reinforcement that not only adheres better to the concrete, but also can provide more structural stability. Now, you wouldn't use general purpose concrete in building a skyscraper, you're not going to use general purpose reinforcement bar in building a skyscraper or an apartment block or stuff like that. So where a lot of the contention, I think, comes in for reinforcement bar is if you go down to Lowe's, or in Australia we go to Bunnings and buy your general purpose reinforcement bar there, it's going to be your low carbon, low to medium carbon general purpose. Whereas if you find some in a scrapyard, construction builders specifically, big builders that build apartments and stuff like that, they often sell their off-cut or scrap reinforcement or steel to metal recyclers in order to make some money back from the cost of building. So that can be everything from reinforcement that has been used in their concrete driveways all the way up to what's being used in the foundations and up through the concrete of the building. So it can be a mix of the general purpose reinforcement that you've got for the sidewalk right up to the high carbon reinforcement bar. And I do that high carbon in quotes because high carbon reinforcement bar can be up to generally 0.6% carbon, which in a steel scale, so from 0.35, which is on the medium carbon range, up to 0.6 carbon, which is in the high carbon range. So high carbon reinforcement bar falls into that medium high carbon range of steel. It's not going to be super high carbon, but it generally can be classified as a medium carbon steel, which means it can actually harden in water. So if you've gone to your scrapyard and pulled some reinforcement bar, you might have one piece that is a general purpose piece, which is soft and will bend even after heating and beating, and then you'll get another piece which you can heat up, and then as soon as you quench it, you go to straighten it out, and it snaps because you've got two entirely different pieces out of the same pile. Right, it could even be bundled together because the thing is, when they on work sites, when they cut them off, they might bundle and tie them all together in the same sort of lengths. So you might buy a bundle and it still be all sorts. The reason why I push this so much is because you've got to remember, engineers are working on these buildings. There's no way that they don't know what's in the steel and they don't know the tolerances. Here's how another test that they use for steel rating is called the Young's modulus, or the elasticity content of steel. The difference between general purpose reinforcement and 1080 unhardened 1084 is general purpose reinforcement is 200 to 210 gigapascals of elasticity. 1084 has 190 to 210 gigapascals. It's a matter of 10 gigapascals difference in unhardened 1084 to standard reinforcement bar when it comes to elasticity. So there I've covered your general purpose and your high carbon steel reinforcement. Now there's also two more classifications. So the first one I'm going to go into is stainless steel. Stainless steel reinforcement, of course, also comes in the low and high carbon classifications, but you can generally pick apart stainless steel because, of course, it's going to be bright and shiny. But that has uses in marine, particularly in marine construction, where it's a lot of salt water because, of course, stainless steel is corrosion resistant. Depending on and just like in stainless steel, there is a whole range of different types of stainless steel reinforcement, not only in the low and high carbon, but in the different chromium and contents and stuff like that, in order to specifically match what it's being used for. That said, it's also much more expensive than your standard reinforcement bar.
Right.
The last type of reinforcement is what's in the US is generally known as European reinforcement bar. In Australia, it's known as pull bar. Now, this is a reinforcement that has a higher content of manganese. Reason being is so that it is much softer than your standard steel, because in pool, it's generally only used in Australia, as far as I'm aware, in pool, ponds, spa, construction, because it is easy to bend by hand once you're in the pool and stuff like that, and also with heating factors, with your expansion and contraction of concrete and stuff like that, it's able to expand and contract with the concrete a lot easier, rather than resisting that and causing cracking while still supporting the weight of the water.
Yeah.
So that's 4 different types. So if you get some, for example, European Rio or pull bar, and you forge that's going to behave, and it comes in the same sizes as up to 16 millimeters, which is, I think it's 5/8 of an inch for you guys. So pull bar can come up to 5/8. Now, when it comes to reinforcement bar, standard reinforcement bar, it can be from 6 millimeter, which is about 1/8 of an inch, all the way up to 50 millimeters, which is nearly 2 inches. I think it is 2 inches, so 2 inch diameter reinforcement bar. So you've got a wide range of thicknesses that can be reinforcement bar. Now, I mean, as you would have seen, and Sally and a lot of the guys that have been with the with church for a long time and know who I am. If you go back to some of my early videos on my channel, I actually made a hardy cutoff, a hot cut, out of a piece of, I think it was 32 millimeters, so that's about 1.5 inches reinforcement bar. And that's still, I still use that to this day. I occasionally sharpen it. I tried hardening it. It didn't get super hard. It got hard enough. But that's because I knew that 32.
Yeah, to be honest, a hot cut doesn't, you don't really need to, as long as the material is a sturdy material,
Yeah. But I mean, that was back in the early days of me restarting blacksmithing, and I wanted to test if it got hard. I knew it was a medium carbon steel, knowing what that had been used for in the past. It was actually that piece of reinforcement bar that I had would have been used as a support for a bridge. Right. So it was actually used in the upright columns for a bridge. So I knew it would generally be one of the high carbon or medium carbon steels. Now, there are different ways to tell apart the reinforcement bars. If you manage to get the section of the bar that actually has the standard of your country punched into it. Now, because your high carbon will have a different classification, that changes country to country. the US standard for reinforcement is different to the European. So there's generally about 5 different standards used across the world. There's the Australian New Zealand standard, the US standard, which is, just a second, let me see if I can find the information on it. Nope, I must have put it away. So there is the US standard, which has a different numbering system.
It's all the same. It's all the same carbon contents and structural content.
Yeah, across the board.
It's labeled differently. So the point you're trying to make is, depending on where you are, check.
Yes.
Based on that.
That's
for you to say, and I'm just throwing out random letters and numbers here, for you to say, this rebar is, ASCI 76.
Yeah.
And
for example,
somebody in Europe going, I don't know what that means, mate.
Yeah.
Yeah.
So, for example, the US standard for general purpose reinforcement bar is generally ASTM A followed by a number. So that number will generally designate its purpose. So, for general reinforcement bar or grade 75, that will be ASTM A 520 or 520, right? Whereas the European standard is generally a BST number. The British standard is a GR number, or the Indian standard is an IS number, whereas Australian standard is AS/NZS because it also applies to New Zealand.
Yeah.
So, but generally those numbers are only punched on the end of the bar. So if you've had and depending on the size of the bar, here in Australia we generally sell them in standard on for example 1/2 inch or 12 millimeters and 16 millimeters or 5/8. They're generally sold in 6 or 12 meter lengths. So if you get a 6 meter length, on either end it'll have it punched, but it's only going to be the first 5 inches where those numbers are punched. If that bar's been cut or shaped in any manner prior to its use or even during use at the construction site, those numbers are going to be missing. So there's no guaranteed way, unless you buy the reinforcement bar new, to know what type of reinforcement bar that you have, particularly if you bought it scrap. If you bought it new from Lowe's or something like that, or Bunnings, or whichever hardware store applies to your current country, that's going to be, you're going to be able to find those numbers and look them up. But particularly when it comes to found bar, just like any found steel, you need to test it first
to know what you're dealing with.
That's exactly right.
Let's go to the comments here, because there's been a lot of comments about the stuff that you've been talking about, and comments and questions and such. So let's let you take a breather for a second and read into some of those. First off, also hello the people who popped in. I didn't want to interrupt Adam there, but yeah. Is it possible to forge weld rebar? Absolutely. And somebody's saying, the comments are jumping around for me. I've forged rebar before, and it's really hard to move. Why is that, Chewy? You probably had one of those good, sturdy, higher carbon rebars. And then the people, let me see. Yeah, and again, like rail spikes, when we say a high carbon rail spike where it's got stamped HC is not necessarily high carbon as a bladesmith would assume high carbon. Higher carbon than mild steel, So while Adam said earlier that some Rio has the up to 0.6%, which is, and again, not a bladesmith, so I tell people that constantly. I don't know what.
The general lowest amount that the lowest new steel that bladesmith like to use is generally 1075. You can get away with 5160, which has higher alloys in it. But generally speaking, the lowest carbon content you want is 75% because that's still classified as a spring steel. Lower than that, you get into your mid-carbon steels, your tougher steels, stuff you use for hammers and stuff like that, but not necessarily for blades.
Mm-hmm.
Hey, what did we learn on the 5160 week? 5 means chromium, 1 means 1%, and 60 is carbon.
So 60% carbon?
No.
Point
0.6.
0.6.
Is it 0.6 or 0.06? 0.6. 0.6.
0.6.
Okay.
Yeah,
So
0.6,
yeah. So
0.6 carbon, 1% chromium.
So 0.6 carbon will make a decent knife. Decent. Notice I said decent. I don't know blades, so I'm not going to say it'll make a great knife, but it will make a knife. So can you make rebar into a knife? Yes, but you got to have the right rebar. Just like you got to have the right
and you
steel.
also got to remember that with rebar, it's within a tolerance. So your high carbon rebar can be from 0.36% carbon up to 0.6% carbon. So so for example, if you put that in a 51, so you might have 5130 to 5160. That's the range because that's acceptable for engineering. It doesn't have to be. It's spot on, but it doesn't have to be spot on. Because the difference between the 36 and the 60 in terms of elasticity and strength doesn't make too much of a difference. It will generally be in the and that's the range. That's the acceptable range on the spectroscopy on the spectroscopy scale. It's allowed to be when they test because all reinforcement bar is tested before it's put into buildings. As someone that worked in reinforcement manufacturing, whenever we did any sent any reinforcement bar out, we would have to take 1 meter of that reinforcement bar and send it off to get spectrally analyzed before we could ship it out to make sure it was within the tolerances. If it wasn't, then that whole bundle, that whole pack of reinforcement bar that was made together would then have to be downgraded into general purpose, and it would be practically written off because it didn't meet the standards for the construction. So, a piece of high carbon reinforcement might generally have between, 0.42 and 0.55% carbon.
Yeah.
So is it good for a knife? You can make one out of it, but I wouldn't say it's good. But if you're using reinforcement bar, what are you doing making knives out of it?
Right. And that boils down to the whole thing of it's the age-old comments and stuff that you hear. Oh, that's not a good steel. Why not? You can't make a knife out of it. Is that the definition of a good steel? Is the definition of a good steel, can you make a knife or a tool out of it? No. The definition of a good steel, as a blacksmith is concerned, is can you forge it? Can you shape it in the fire, at the anvil? So it's like, are you going to forge it, build a sculpture or something, and then it's going to fall apart because it's not a good steel? That would be not a good steel, But
So what I've got here, and I got nothing on Adam's work there on Rebar, because I mean, like all I had, basically all I have is some history stuff, and I mean, like, at this point, I mean, like that's way overshadowed
by everything you just said.
Yeah. So what from personal experience, I find it for me, just personally, I find it as problematic as working those I don't know if you remember or whatever. I'd get those BOP bolts that are 4140.
Yeah.
And it's like it's basically it's free 4140 that all you got to do is grind the threads off of. Well, I find rebar to be as problematic as that because the surface is got to be prepared first before you can really do anything with it. And I mean, and so I'm like, I've kind of avoided it just because of the the patterning in rebar specifically, that I'm like, all right, because I haven't had a project where I needed that pattern. And I've had some ideas for it, and oh yeah, I'll pick up some rebar and do that. And I'm like, wait, now I'm not gonna buy rebar to make that project. I'll wait until I find a piece.
Right.
But
Right.
but so I haven't done a whole lot with it, and even that time I made the tarp stakes. In all reality, I didn't need to heat it up at all. I could have just put it in a vise and bent it, you know.
Right. Right.
But I went to all the trouble of forging them and all that, and I'm sitting there and I was knocking them out quick because I was doing the taper on the end, and then the bend all in one heat, and so I was whipping them out really quick. And I'm sitting out there in the forge, and I'm just I've got like 12 of them in the fire, and pull one out, tape, bend it, throw it on the ground. And my grandson walked in and wrapped his toes around one that had just cooled to a black heat. So yeah, that was fun.
Aimless has a couple questions and comments that I want to address. So rebar is no better than a rail spike? Question mark. I didn't say that. I used the analogy of the rail spike being, the argument of high carbon rail spikes and whatnot. I used the analogy. So I didn't say it's no better. I only compared it as the discussional aspects of the two steels. Like, when somebody says, "Oh, it's a high carbon spike," kinda, or like you said earlier, it's hot dog steel. Not really. It's the analogy is the same, but like no, they're not the same type of steel, unless they are. But Adam said a whole bunch of numbers, and I don't know how that applies to rail spikes. So it's possible. I don't know. I'm not saying they're not the same, but I am saying this. What I had said about it, I was not saying they're the same. First off, I'd like to say hello to the people who popped in again. Hey, Paul. Hey, Canadian Necktie. What's up, Davey? How you doing? And Alan. I saw your name. I saw it. Alan. Don't run. Alan Kennedy. How you doing? Good morning. And then let me see. Trail Dust said something that I kind of want to address, but anything makes a good butter knife. And in my opinion, being a non-bladesmith, okay, any modern steel will make a knife. Is it a good knife? Compared to what? Compared to knives of ancient history? Absolutely, it's a fantastic knife. I could take a mild steel bar, make a knife.
I'd like to interject. You can make a knife out of all kinds of materials, and it doesn't have to be steel. I don't really want to expand upon that much further at the time being, but
absolutely, it's just a rail spike knife. To me, if I were to make a rail spike knife for my shop, to use as a knife, it'd be a great knife for my shop. Am I gonna have to resharpen it? Yeah. Does that mean it's not that it's a bad knife? No, not to me. So that being said, and here's
the only that just brought up a sore spot with me. The only like rail spike knife that I ever did that I sandmined, I sandmined in a piece of that 4140 that we got from Dan Zappa down into the spike, and then I made a decent knife with a heck of an edge. It was one of the few knives I've made that'll shave, and it's like literally the only thing that's been stolen from me.
Right.
like since I moved into this house, well, I get that it was I left it sitting on the concrete in the driveway, and then the next day I was like, I gotta put up all my shit from yesterday, and that was gone. Sorry.
Hot mic, but it's no big deal. Mm-hmm. Another thing,
and I'm like, really? I had a leather wrap handle on it and everything, and I was like, man, I put a lot of effort into that.
Yeah. Aimless brought up the thing that always comes up during rebar discussions. And I would like to kind of go into this because I have what I feel, calling it hot dog steel, and because it's made from recycled steels.
Okay, so there's two thought processes on that. Okay,
if I may real quick.
so on the first one, so what?
If I may real quick, because I've
Go
heard
ahead.
two explanations of why it's called hot dog steel. One is because it's a whole bunch of different steels melted down to make one random billet of steel, and the other one is, well, you can take and cut off foot sections of the same bar, and each one will be a different type of steel. Which does not make sense to me.
Those fall along the similar thought process. I can expand upon that with a little bit greater detail.
By all means.
Okay, so the reason you would think that, and I'll go through the way I think it goes versus the way I think most people think it goes. The reason you'd call it hot dog steel is let's say you're taking this particular batch of rebar happens to be made in Sichuan, China, whatever, and this is a melted down Chevrolet pickup. Okay, basically this section of rebar we're talking about, and so you've got probably 6 different grades of steel that go into this thing, and basically the whole freaking vehicle goes in there, and the stuff that's like aluminum and brass, all that stuff melts out real early and gets well, yeah, no, because the steel is still solid at the time, so this stuff is pulled off the bottom. And then the steel is once the steel is all melted, which includes the cast iron, the high carbon steel, the sheet metal, the mild steel that the frame is made of, because it's made to be soft and crumple. All of that stuff melts together, right? And so you think about this and you think, well, you're going to have pockets of high carbon steel and pockets of low carbon steel that are sitting in this huge crucible, which is basically, which this crucible holds somewhere in the neighborhood of 2.5 to 5 tons of molten iron, steel, whatever you want to call it, and then it's poured into the things that extrude it and what have you. And so you wind up with these little pockets that are higher carbon than others because of the cast iron that's included in the mix and the mild steel that's included in the mix. So that's why people would say, well, that's why you can, in the same 10-foot section of rebar, you can have like 3 different spark tests or 4 different spark tests and 4 different, rates of hardness. Okay. Now, that makes complete sense, you would think. I think that so when the steel is molten, because it's not exactly evenly heated from all 360 degrees at the same time. It is primarily heated from the bottom and the sides, and so what this causes is convection. So inside the molten, and it's kept molten for quite some time. It's not like as soon as it goes liquid, they skim off the slag and pour it. It's kept molten for the better part of like 12 hours. And so while it is in its molten state, there are convection currents in the liquid running through it, where the hot stuff on the bottom is moving up to the top, and as it cools, it's moving to the inside and sinking back down. And so in essence, the convection currents stir the molten steel and give it a uniform carbon content and a uniform alloy. Now, the alloy that comes out of that particular crucible may not be the same as the next crucible, but in my opinion, all of the steel that comes out of that crucible, kind of like we were talking about shear steel or rod or whatever, all of the stuff that Woots. All of the steel that comes out of that crucible is going to be fairly uniform.
Right. And that's what I'm saying. That's what I'm saying. When I see people arguing that they'll take one piece of steel or one piece of rebar and they'll have, mild steel, high carbon steel, mild steel, that makes no sense to me because of exactly the way it's made. It's melted down, and they don't melt it down and go, "Oh, it's liquid, quick, extrude it." it holds.
Well, I see. I can, and Sally, I can support that with numbers, because I earlier on tonight I went through the general or the main components of what's contained in reinforcement bar. Now there are other alloying metals in there. You've got nickel, you've got chromium, molybdenum, vanadium, copper, tungsten, titanium, tin, cobalt, aluminium or aluminum, and even neobium, which I don't even know what that is.
Niobium.
Probably
Niobium,
some beryllium.
Yeah. Now, for example, with the aluminium content, general purpose reinforcement steel contains less than 0.001 to 0.004% per weight.
Yeah.
right? So it is insignificant amounts. It's got most general purpose reinforcement bar contains more copper than it does aluminium. It can, and when it comes to tin, it contains 0.008 to 0.030. Tungsten 0.007, less than 0.007, less than 0.001% titanium. These alloying components are tiny amounts. And the reason why they're generally not discussed is because they're so small that they're insignificant. And as Sully said, when it comes down to the smelting process, he's absolutely right. Compared to, medieval...
They don't use a swizzle stick to stir it.
Exactly, but also compared to medieval smelting techniques, modern smelting generally reduces that steel to liquid. So it's going to be more or less uniform. And as Sully said, per crucible, we've all seen, for example, and a great example of this off the cup is the steel manufacturing plant in the Terminator, where they've got these massive, and I'm talking about the original one, where they had these massive crucibles of steel, of molten steel. That's how steel is made. It's melted right down in order to get that consistency. Whilst it might be a hot dog steel in the sense that everything might go into it, the general consistency of it is going to be the same. But you also brought up a really interesting point. It depends on where it's made as well, because China will have a different standard to America. And,
yes.
And I know this is true because they have a different standard to Australia. I worked for a company which the reinforcement bar was manufactured in Australia, and we generally had a better quality when it came to the consistency of the steel than one of the competitors of the company that I worked for, which imported their reinforcement from overseas.
Yeah.
Because we had to have our steel, according to Australian law, tested for every pack. 1 meter had to be sent away. Our competitor company had more steel sent back because their steel didn't reach the standard for the construction that was happening. So high carbon, for example, would be downgraded.
Yeah.
So a decent example of that disparity in quality or restrictions, however you want to look at it. I work in the oil field, right? And there's this particular component that we have on a drilling rig. It's called a mud pump, and it is huge. It is heavy, whatever. And generally, this is 20 years ago. The big mud pumps that we had were called a PZ8 by Gardner Denver, and it was called that because it had an 8-inch stroke. And a Gardner Denver is a U.S. made, all U.S. source components, whatever. And and they're fairly pricey. You run about $1 million a piece. And when I first started running a bed truck, we started getting these things that we called Chinese pumps because they were a knockoff of a PZ8 made in China. But in order to meet the same specifications for for strength and whatever, the cast iron of the casting was 50% thicker all the way around. So instead of this mud pump weighing 60,000 pounds, it now weighs 90,000 pounds. And that's, we were like, them crappy Chinese pumps. Well, the quality, the end product was the same, but you had so much more metal in it just to make it to meet U.S. equivalencies. Yeah.
Now I'd like to hit the comment section for a bit because we just had a blast of awesome comments.
I was gonna interject one more thing quick, and then I can step back.
Oh, yeah.
This is more of a question. This is more of a question than anything because I don't know. Okay, so in the manufacturing process of the steel that say goes into rebar, these crucibles are not sealed. They're open crucibles, and I don't know if they're air air blasted or whatever, like in a blast furnace or what have you. But do you reckon that the exposure to air over the entire time it's molten would cause the steel to decarburize to a certain extent? I mean, like, because Adam was talking about the carbon content in general rebar being so low. I was wondering if maybe the open air process contributed to the removal of carbon.
Which brings up my question too: do they know this, and do they add stuff specifically to maintain a level of consistency or specifications? But before we get into that, because that is an excellent question, does the process reduce certain, burn off certain qualities, and do they compensate for that, or do they just go, nah, steel? But starting with Wayne Heights, might be called hot dog steel because it's extruded like a hot dog. Roy saying modern steel is uniform and made to strict standards. All of it is graded in one way or another. Yeah, I think so. Merry Christmas, everybody. People are popping in saying Merry Christmas. Another Steve Parsons, how you doing? Goes, yeah, use rebar for all kinds of stuff, holding billets and making art. Yep, tons of uses. Aimless kind of confirming what you were saying there, Sully. The plant he worked for used an arc furnace, which is a violent process. I doubt there would be pockets of certain steels happening with that process. Right. Mountain Home. This is probably one of the more comments, or one of the more common comments arguing against, rebar is crap. If they're using it in bridges and such, it has to be the same all the way through. Yes. They didn't build skyscrapers and bridges and dams with junk steel that has such varying properties as not to be reliable. Period. And that's like the bottom line is, yes, that's what, the whole process we're talking about. And we're not so much trying to convince you guys, we're trying to give, a simple answer when you see this argument presented in conversation. I had to say, excellent comments. We'll get to them. Scientists be talking. Because I can't get an urgent word in edgewise. What's up, Rory? Imagine the liabilities of large construction companies if they used unreliable reinforcement. Chewy wants to know how close to hammer steel is rebar, and I think that depends on the Speargrass said, depends on the rebar, because there's different grades. Let me see. Morning Corey, trying to get, rebar is frowned upon but makes for good conversation. Rebar is only frowned upon because people don't truly understand it. Okay? And Roy, I've got some rebar that is re-rolled railroad track. Say that 10 times fast. All right, so with that, original question from me and Sully, and then we'll kind of, I'm hoping the scientists in the group can touch upon some of them comments. Now, Adam knows more about the manufacturing process of rebar than we do, or than I do, for sure. The open top thought of it losing any, the decarburization, and my thoughts of, well, do they compensate for that by adding specific steels to it to make sure that it maintains a certain level? Like when they're pouring it, do they go, we need this quality of rebar, let's keep using this quality of material and account for this, that, like baking, let's add some flour for carbon, like what's up, talk to me, buddy.
Okay, so as John Brunel said in the comments, right, although carbon is very slow to burn off compared to other elements, they don't generally add carbon. But there's two reasons for that. One, even though it's molten steel, they test it during the smelting process. They will get a ladle, they will pull out the steel, they will cool it, and they will spectrometrically test the steel during the manufacturing process. Then
all before they pour it or extrude it.
All before they pour it, and then they will test it after they pour it as well. right? So that's already been tested twice. Then when it gets to a reinforcement facility like the one I used to work at, once we bent, like, because it goes to a reinforcement facility, generally a wholesaler. Some of the biggest in the world are Smog and Steel. Rio Tinto is another one, and they have their different company, their children companies, the subsidiary companies that sell it to the public, and they then of course it's bent and shaped. It's generally, so you generally get hot rolled steel when it comes to reinforcement bar. Then it's cold bent. So most reinforcement bar is cold bent, and it's cut. And again, it's tested. It's cut there at those facilities, and tested again. So most reinforcement bar actually gets tested minimum of three times in the manufacturing process before it gets to a building site. So, but you've also got to remember that when it comes to reinforcement bar, they're going for a tolerance range. So, like I said, general purpose reinforcement bar has a carbon content between 0.19 and 0.35%. So it can be in that range. As long as it's in that range, it's within tolerance. So it can be from 0.19% carbon up to 0.35. And if they know they're using it for reinforcement at the smelting plant, that's what they're going to test for. Unlike, I mean, even 1085 knife steel has a range of 0.8% carbon up to 0.93% carbon. It's a tighter range, but it's still a range because it's a tolerance.
Yes.
You're never going to get exactly 0.8 or 0.2 or 0.4 across a whole bar. It's not going to happen.
Of course, John.
So that's why it's a range, and people forget that those tolerances exist. Yeah. Right. The only time when tolerances are really, really tight is when you're machining something for a high performance vehicle.
Yes.
Right. But even then, if you got your alloys that are used in a high performance sports car and tested one piece against another piece that came off the same block, the spectrometer tests would show slightly different ranges because again, there's no way of making it pinpoint when it comes down to smelting of steel. They get as close as possible. So when it comes to the burning off of carbon is also if you look at when you smelt steel, carbon will burn off at some rate, but generally your things like your aluminium will evaporate and burn off first. Your copper will evaporate and burn off first because it has when it comes to its chemical bond with steel, it has a tighter chemical bond with iron than copper does with iron. So copper will separate out and everything first. So generally they don't need to because, again, if it's a hot dog steel, you might, and I say that in the sense of everything's thrown in, you might have stuff that is, your 1095 car springs going in with, your low carbon, car body. So, those then that might bring the average down to, say, 70% carbon. And then through the smelting process, it will bring it down. And then during the smelting process, they'll test the carbon. And then when they pour it out, they test the carbon so that they can go, okay, so this is the classification for that crucible of steel. That's what we're going to stamp it with.
Yeah.
So it's going to be low carbon, or it's going to be the high carbon reinforcement because our tests show that that has this carbon content. They don't pour and pray.
Yeah. Now Paul brought up they don't use scrap rebar for bridges and high rises, but it is used for driveways. So the question would be, where does your rebar come from when forging rebar? Absolutely, but crap rebar for driveways and stuff. The whole point of this is while it's a lower grade, does not mean that it is unknown steel. It's still got its range. So yeah, it's absolutely, it's like what they use, as he said way out in the beginning, what they use for, sidewalks, driveways, roadways, just general roadways, not bridges and high rises. That is a lower grade, lower strength, I guess, rebar, but it still has specific properties that it needs. They don't just go, oh, we've got some of this rebar, it's half aluminum, half copper, and it's got, just a little bit of steel pockets in it. That's the whole point of this is the process. And as John says, his job is to test and do carbon and silica adjustments while steel is melting, and he runs furnaces. Like, it's right there. It's somebody whose job is to monitor the quality of molten steel before it gets turned into what it's going to be turned into. And as Sully said, the convection currents inside a crucible stir it so that you're not going to get, as it's extruding, this used to be railroad, this used to be, brake pads, this used to be, this. It's all now one homogeneous, or not homogeneous, one consistent bucket of molten metal,
Homogeneous is an accurate description.
Is it? Okay, I thought homogeneous was more.
It means equally mixed with it. Equally mixed.
This steel has achieved homeostasis.
Right.
And then Chewie asked.
Now it was Bohr that asked about the. It wasn't Bohr. It was Chewie that asked about where can you use reinforcement bar to make hammers. It's a depends. I mean, at the end of the day, when it comes to your high carbon reinforcement, particularly your bigger sizes like your 50 mil or your 2-inch. I have a piece of 38 millimeter, which is, I think it's about 1.5 inches, 1.75 inches reinforcement bar that I made my hot cut out of. That I intend on trying to make a troll hammer, or a mild hammer out of. But I'm trying to get hold of some 50 mil reinforcement bar to make a hammer out of, simply to say I've done it. Again, when it comes to stuff that goes in bridges, it's generally what is in the reinforcement called high carbon, but it is generally 0.36 to 0.60% carbon. So it could make a hardenable hammer, particularly if it's in that mid to high range for reinforcement bar, the 0.4 to 0.6%. It would probably make a decent hammer. Without getting it spectrometrically analysed, you wouldn't know exactly how much carbon's in it. But if you can get that high carbon, particularly the large diameter reinforcement bar, 50 millimeter or 2 inches, it's even if it doesn't make a super hard hammer, does it matter? I mean, at the end of the day, a hammer is a tool which you're going to hit stuff with, and as long as it's harder than the hot steel which you're hitting on, it's going to deform the hot steel, and you're going to end up with a hammer that works.
Yeah.
And particularly because it's made out of reinforcement bar, if it does end up with some marks on the face, you can always grind it off, or use it for tooling where you've got a high carbon piece of a punch or a chisel or something like that. You can use it on the back of that without having to worry if it's it breaking or you ended up damaged.
Right, and I have to keep in mind I'm reading comments, watching this, listening as much as I can. One big benefit to rebar to YouTubers is it makes for great YouTube videos because it is such a contested, controversial topic. He goes, gets the neckbeards talking. Yeah, absolutely. I made the mistake of not advertising this show even though I had fully intended to, I forgot to advertise that this week we were going to be. Had I advertised that we were going to be talking rebar, I'd probably have 1,000 people in here all screaming and yelling, "You're wrong!" But for all of you watching, anytime the discussion comes up, share this link, and this is excellent educational material for this argument. The whole, is rebar a good steel, or is it a crap steel, or why should I use rebar? This, that, and the other thing. It's excellent information being shared here from legit sources. It's an excellent topic. So sorry.
Yeah, I'm just to let you know, I'm not a metallurgist. It's just someone that I worked in the industry. I worked in steel reinforcement, and as part of my work, I'm the type of person that when I start working in an industry, I try and find out everything about it. So I got to know the engineers and the that we had working in the office that did the designs. Because when a building is designed, they have to bring it to an engineer, and the engineers do it, and then they take it to a reinforcement structural engineer in order to make sure that the reinforcement is going to match the designs of what's happening. So the reinforcement engineer, they have to know everything about that construction and everything about the steel in order to make sure that the reinforcement bar is going to match the tolerances and the weight distribution and the stresses depend on what's going to happen. Now, think of it this way. Imagine if they used a hot dog steel on the Hoover Dam. What would happen?
I just had a dirty analogy. You'd get a lot of sploosh, if you know what I mean.
Exactly, because and it's not only and the thing is, it's not only the strength of it. They also have to take into account corrosion resistance, expansion due to corrosion, because as we all know, when steel rusts, particularly when it corrodes really bad, it doesn't just stay the same size, it expands. So that can cause cracking in concrete and all sorts of issues. Mm-hmm. So these are things that are all highly tested and are known by these engineers and structural engineers and all that type of thing, in order to that's why buildings have lifespans, because they know how long the concrete, the reinforcement, the structure of that building will last, according to the information they had regarding the materials in it. So yeah, it can be a disaster, and it's happened. There are places you can bring them up around the world where buildings have collapsed, and one of the examples I came across during my research for this show was there are literally dozens of reports done on an apartment building in Nigeria that was built using the wrong type of reinforcement steel. Yeah. This is an apartment building. It was several stories tall, and they used a low carbon, one of the general purpose carbon steel, general purpose reinforcement bars in this building, and it lasted probably 8 or 9 years before the building collapsed. And they did a spectral analysis on some of the reinforcement bar that they pulled out of the rubble, right? And it was at the top end of the general purpose reinforcement bar, right? It was generally the point, 0.33, 0.32, 0.3% carbon, but it was still general purpose. It wasn't the high carbon that's required for building, multi-story apartments. Yeah. So so these decisions and the content of what's in these reinforcement bars can make a big difference to what's actually happening.
Yeah, absolutely. And that's another checkbox point to the argument of you get the semi-educated people, or the people who, as Trail Dust says, I heard it from a guy who knows somebody who saw someone, my brother's uncle's cousins, nephews. I heard it on Facebook. Trust me, bro. People who they hear something, and because they don't know, and it clicks like, oh, that makes sense, they pass that knowledge on as fact, and they say it with such conviction that other people believe it, and over the years, it becomes fact in people's minds, and even though there's empirical evidence that it is not in fact true, much like Roy fighting and telling people that flux is not metal glue, you can't use flux, blah 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 blah, do not use flux. Flux is magical. Flux, you could take and hold the steel, dip it in the flux, and it comes out forge welded. No, I can't even continue that joke. But I mean, big point is most of this argument comes from uneducated or lazily educated people who believe something, hear something, believe it, Google search it, and then find a dozen articles of people talking about it and go, well, enough people talk about it, so it must be true, instead of going the full research route like Speargrass and Sulbert did, and and actually look into the science of it, you know. So,
at the end of the day, the easiest way to think about it is even high carbon reinforcement bar is never going to make a great knife or as good a knife as a known spring steel will. It won't even make as good a knife as a car leaf spring.
Right.
Because it's not designed for that. It's great to practice as blacksmiths and as scrapsmiths. It's great to practice on, and again, it comes back to that argument of up to 3,000 years ago, they were making swords from iron that were better than bronze swords. So this is wrought iron, not high carbon steel that we have nowadays. They were making swords and knives and daggers from wrought iron. So you can make a usable knife out of reinforcement bar. Is it going to be as good as modern high carbon steels? No, it's not going to be, because it wasn't designed for that. It wasn't designed to make that. But you can still make a good, usable and sharp knife out of reinforcement bar.
Yeah. Is it going to be as quality of a knife as like an 80 CRV or whatever? No. But then that whole discussion is a discussion in and of itself, where you go into, you know, just like there are blacksmith snobs who go, oh, you can't forge unless you have this, and you can't do this unless you have that, and that's not good, this isn't good, blah, 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 blah. You know, you have bladesmith snobs, too, where you go, it's not a knife unless it's made out of knife steel. The point would be, there are better materials to make a blade out of, but define the definition of a knife. Look up the definition of a knife. Like Sully said, you can make a knife, a legitimate, defined knife, out of just about any material. You know, it's just, I think I even seen a guy make a knife out of gelatin. Okay, he did something and like it hardened and whatever, and basically he had like a jello plastic billet that he then sharpened and used to cut tomatoes. That's a knife. Now, is it going to be, you know, a long-lasting quality knife? No, but it's still a knife. You know, to argue, to argue semantics and go, oh, that's, you know, you can make a better knife. Yeah, I'm not saying you can't. You know, I'm not saying you can't. Blades, okay, trying not to offend anybody with this, but bladesmith snobs can be some of the most brutally critical people, because if you don't use exactly the process and exactly the steel that they would use, then you're not a bladesmith. And it's like, and that's not to say every single bladesmith is like that. Just you come across them and it's like, you know, lighten up a bit. Life's fun.
And at the end of the day, if you're not using it to make tools and stuff like that, you know, reinforcement bar is a great thing to to practice on, to get your technique down. Yeah, you might come across some times where it's a bit harder, which means you need to get the steel a bit hotter, but that's just general purpose blacksmithing anyway. Sometimes you're going to come across steel that's a little bit harder to move. You've got to hit a little bit harder or get a little bit hotter. And the thing is, reinforcement bar, and this is kind of a throw over the Sully. The reinforcement bar, or using reinforcement in construction and concrete, is not a new thing. We've used reinforcement steel since steel was made. However, prior to the introduction of steel, reinforcement was wrought iron. There are pre-1860s buildings with wrought iron used for reinforcement. Reinforcement, a common reinforcement particularly across Asia, inside concrete structures, is bamboo. The ancient Romans, there's evidence of ancient Romans using iron bars to attach, some of their stonework to some of their concrete or mortar work, going back thousands of years to the age of Roman, and that was iron. So reinforcement has been used for a long time, and particularly when it comes to scrap, it's again, it comes back to that. If you don't know where it come from, test it.
Yeah.
All right. But, you can make a knife-shaped object. It might not be the best performing knife in the world, but like Yarmez said earlier about, making a shop knife. If you're practicing knife making and you want to make a shop knife, go ahead. It might not be something that's of the quality to sell, at the local fishing store, but it's still something you're going to use. If you want to try and make a hammer out of a decent size reinforcement bar, go ahead. You're not going to be selling it, at the local hardware store, but if you're using it for yourself, why not? It's a tool. It's designed to be used, and eventually it's going to wear out. None of us buy hammers with the thought that we're going to whilst we'd like to, none of us buy hammers with the thought that we're going to hand them on to our great-great-grandchildren. Yeah. They're tools. They're to be used. If they wear out, so be it. I also saw someone in the comments ask earlier if reinforcement was forge weldable. Yeah, of course it is, but of course your general purpose low grade reinforcement is going to be easier to forge weld because it's easier to electric weld. It's classified as weldable. So just like your carbon steels are generally harder to weld, and your mild steels are generally easier to weld. Same goes for reinforcement steel. It's your general purpose low carbon reinforcement steel is generally going to be easier to weld than your higher carbon stuff, but it again depends.
Yeah, I mean, absolutely. And if I may break a moment from the severity, Robert Lonis brought up an excellent joke, and I counteracted it with excellent truth. He goes, "I tried to make, you can't make a knife out of everything. I tried doing it out of a hot dog." And I go, "Did you stabilize the hot dog first? Because if you can get the material to become a solid, hard piece, you can get it to make a knife. I mean, a knife out of Jello. He did some processes and made the Jello almost like glass or like a plastic glass." If you were to cactus juice and vacuum chamber and stabilize the hot dog, or stabilize the hot dog and then put it in do some stuff to make the hot dog hard. I'm trying to really be appropriate here, tickle it a little bit. No, but I mean, yeah. If you could turn it from not being into a hot dog into being a solid piece of what's the word? Enamel? Not enamel. Stuff. He probably could. Alexa, play Baby Shark. How many people are going to go, "No, not again"?
On that note, Roy makes a really good point, about using prior to Forge and Fire, Bladesmith could use anything right back through history. Didn't Roy recently make a video on, surface hardening an anvil with a compound?
Yeah, he did. I haven't caught it yet, but yeah, he did.
Yeah, and so that stands to reason that if you wanted to make a blade-shaped object that could potentially hold a decent edge at least for a little while, you could quite realistically make it out of a medium carbon, or a high carbon reinforcement bar, which is generally medium carbon. Add some of that compound and get it a little harder.
Yeah, yeah, absolutely.
So I mean, there are options, but at the end of the day, it's not a hot dog steel. It never has been a hot dog steel. I mean, think about when the Hoover Dam was built. Do you think they would risk the lives of, tens of thousands, if not millions of people? Because you've also got to remember, if a dam gives way, you're not just risking the people downstream, you're risking the lives of the people that rely on the water. So, if that dam broke, there are potentially millions of lives on the line for what would be for the lack of knowing what's in a material.
Yeah.
So we metallurgy and metal or steel sciences have been very, very well known for decades.
Yeah. Now Roy's bringing up some good points here, and if I may, okay. With the Forged in Fire comment that you started with this, yes, before Forged in Fire, bladesmiths were using whatever and everything, and he goes, it's like the one side effect of the Forged in Fire era of the blacksmiths and bladesmiths renaissance, so to speak, is or revival, not renaissance, revival, is you have these overnight metallurgists, like these people who they have like we discussed in the past, practical knowledge versus book knowledge, or research knowledge, where they don't have a working knowledge of something, but they know they've read it and they deem it to be true, but they've never actually done it, experimented themselves. It's like they hear that this, and this to be true, and like I said before, it's like you have so much regurgitated false information out there that it's it's accepted as true even though it's not entirely true. There's more to it than just that. So it's like they deem themselves, I know metal. It's like I know 80 CRV is the best knife steel to make. Based on what? Example. The tools involved in making the Abana grill is recommended to make in mild and case hardened. There you go. Yeah. And somebody said that they used, what was it? Somebody said they used something. Okay, so I've used a railroad spike as a hot chisel, and then in the same project turned that railroad spike hot chisel into be a square drift because I wanted a square hole, a 5/8 square hole. I'm like, okay, I could sit there and take a piece of coil and bang it out into be a 5/8 square tool steel, but I really only need this for this one project right now. What's 5/8 square steel with a chiseled end? Rail spike. And you know what? It worked like several times over. So using a non-tool steel as a tool is entirely and often, like Roy says, recommended procedure. Good morning, Insanity. I see you screaming at me. And yeah, as Eric says, it's a lot of it boils down to is that people get fixated on one aspect of it, and that's all that it's all that they see in their mind is that one aspect.
Do you reckon? I mean, I don't know. I mean, because I don't look at it. I'm not much of a blade type person, so I don't really. And so I don't really think of things in that respect, because I'm more of like tooling wise, art wise. I mean, just things that I need, whatever. That's what when I see a steel, I think of what I can make with it in that respect. Not so much of like I wonder. In no time does a blade ever come into the thought process, regardless of what I'm looking at.
Right.
But do you think that's not true for the majority of I'd say I wouldn't say everybody, but like the newer people that are just kind of coming into this.
Are you the newer people coming?
You look at like rebar and you're wondering like, can I make a knife out of this or something like that, which is your initial first thought. I mean,
yeah, like, the people who are getting
I would have never looked at rebar and wondered if I could make a knife out of it because I wouldn't have cared.
Yeah, me neither. That's what kind of Roy is getting into or was getting into about the revival era after Forged in Fire, being the majority of new smiths are getting into it to make knives. So, like that makes it difficult when answering questions and stuff. You have to go, they go, they'll take a picture of a random piece of steel. Is this good for a knife? And first of all, what is it? And then when somebody goes, is rebar a good steel? And you get a dozen answers. No, you'll never hold an edge. That's not what he was asking. Like, people assume that the question asked is what you would ask. And if all these people are getting into it to make knives, then they assume so is everybody else. And it's, to be fair... It's a fair assumption, because the majority of people are in it to make knives at this point in, let's call it, history.
And let's call a spade a spade. And when I was on the groups and stuff like that, it was a question that was seen a lot. Is reinforcement bar a good knife steel? No, it's not. Right, it's not a good knife steel when you're looking at making knives. But is it a good steel is a very broad topic.
Yes.
Is it a good steel for what? I'm not going to make a gate, for example, and kind of using Roy as the backbone of this idea. I'm not going to make a gate out of 1095 for two reasons. One, it would be prohibitively expensive,
mm-hmm.
and two, why would I, when I can make it just as well with a lot cheaper material, a more cost-effective material, that I'm going to get just as good, if not better, results, because the steel's easier to move, easier to shape. I can get it in a range of sizes for what I want it for, etc., etc., etc. So it depends. When someone says, "Is this a good steel?" your answer should be, "Well, it depends on what you're making.
Yes.
What are you using it for?
Yes.
Are you making a barbecue grill out of it? Yes, reinforcement bar will make a perfectly fine barbecue grill. Are you trying to make a 6 foot long Zweihander sword out of it? No, it will not make a great steel for making a sword.
Yeah.
You can make one out of it, but it will not make a great steel for one."
And Roy just commented and brings up like the next tier of the conversation. These new people into the field, would then assume if you're not making your tools from steel that would make a good knife, then it's junk, don't use it. That's not entirely true. Like I just said, I've used a rail spike to make a tool. A tool is a tool is a tool. The material just tells you how long that tool can last. You use a better steel, it will last longer. But if you use a worse steel, it's still a usable tool. Now, I wouldn't take a piece of 1/4-inch round stock and try to use it as a 1/4-inch punch because it'll bend easily. It doesn't have it'll start to work and then it'll bend. I've done it. So it's like,
yep.
So to be fair with that, it's possible to, my train of thought just left the station. Yeah.
It derailed right afterwards?
It derailed. It went, like there is the point of that, but that's less of a steel type and more of a dimensions. It doesn't have the dimensions to have the mass and structure to handle being used as a punch. you know.
Right, and by the same account, I've done the same thing you're talking about, where I take it's like, well, I need to drift this hole out a little bit bigger just to get it right. It's like, and I got just the perfect size of mild steel right there. All I need to do is just cut it off, and heck, I can just take it right over to the grinder and grind a bevel on the end, and there you go, Bob's your uncle. You got a drift, and then you go to try to drift the hole, and you whack it with the hammer one time, and it bends over, and you're like, ah, crap.
Mm-hmm.
Well, that didn't work. And so in that respect with rebar, it's not going to be great for everything, but but you're right, dimensionally, I mean, it's got to be appropriate.
Okay, yeah, we got jokes here.
I'm not sure where you were going with that. I just thought I'd kind of continue on
the
path
No,
you
you're
were
absolutely
on.
right. You're absolutely right. Like, stop the stigma of it has to be this, or it has to be that, or it's not this, or it's not that. That, stop that stigma. And again, everybody, anytime these kinds of arguments come up, link this video. That's what we do this for.
And at the end of the day, the only time it has to be a sort of steel is when you're making something to perform a task specifically for that task. And to mention Sam. Sam is a knife smith. Sam is a bladesmith. Sam makes knives for a living. So when he's making a knife to sell to a customer, he will make it out of knife steel because that is what it is for, But he'll also discuss with that customer the design, the use of that knife. How, is it going to be a display piece? Is it going to be hanging off a belt on a fishing trawler to be used every day, depending on the use, and he'll make it for that use. If it's you in your backyard making something for you because you're trying it out for the first time, it doesn't matter.
Yeah, absolutely. It's like, and Sam is an excellent, I wish he was here today, is an excellent example of, he has the knowledge and skill to be a bladesmith snob, but he's not. He's an excellent example of what I would consider a great bladesmith. Somebody who understands the craft enough to discuss the metallurgical aspects of what the tool is going to be used for, in this case knife tool, to be used for, and what is the proper steel to make it out of. But he is understanding enough of the general community and the general sense of, like, hey, to go, yeah, you can take a piece of rebar or a piece of rail spike and make a knife, and not be snobbish about it. He goes, there's a better quality, but if you just want like a little, home use novelty, blade, sure, you use a cheaper steel if you don't want to spend, the money on, a excellent metallurgical steel use. Now, he's just a, yes, Roy's Rebar Toilet Spoon Challenge. Oh my God, yes. I love it, Stephen. Sorry. As Robert said, somebody stole all the rail spikes off the track of my train of thought.
and this is and see, when it comes to rebar as well, a lot of people, we all know Duncan is the rail spike king, right? But the thing, there's a lot of stuff that people get rail spikes and make a whole heap of stuff out of them. You can do all that, particularly when it comes to reinforcement bar. It's cheap, it's readily available, and it's everywhere.
Yeah.
So if you can't get access to railway spikes, do the same projects with reinforcement bar.
Yeah, I am.
For all intents and purposes, it's just as good.
Poor Roy. What's up, Granddads? I am all for anything that gets a true beginner into the craft. And if all they can get a hold of is a bunch of rebar to get started, and then they jump online and say, I got all this rebar, I can get started now, and then you get 100 people going, no, you can't. The dude's going to stop. Let people get into it. And if all they have access to is rebar, and they have the time, money, and wherewithal to take a stack of rebar and weld together a 5-inch billet of rebar and then sink that in the ground, and boom, they have an anvil face. Who's to stop them? Let them do it.
Hey, Yamez, I was just kind of curious. I don't know, like when I first started watching you, like God, 3 or 4 years ago, one of the first streams I saw you, and you were making oyster knives. Was that rebar? Do you recall? I don't know. You were grinding out like a batch of 7 or 8 of them, and I remember that. And
those were actually coil spring, and
okay.
Hold on. My first rail spikes, or my first oyster knives, were actually mild steel, because at that point I had no clue that different steels did different things. Because you were one of my first subscribers. So my process, or my learning process with steels, was really oyster knives. I started with mild steel. I got some, 1/2-inch square steel, flattened the end, pointed it, and then twisted the handle, put a bottle opener on the end. Those did not last very long. I then switched to, again, because I knew that screwdriver steel was a little bit better, because I had an old big pounding screwdriver, and I'm like, this is roughly 1/2-inch, square stock, and I grabbed that and started making it out of that. It was like a freaking 20-inch flathead, and I made like 2 or 3 out of that, and that was pretty good. Remember, I didn't understand why. I just thought, okay, screwdriver steel is better. So I would go to flea markets and thrift stores and buy all the old screwdrivers, and I was making out of that for a bit. And then I got the Chinesian ones, which just started snapping while forging, and that's when I got some coil spring and started making them out of coil spring. And then some beautiful angel of steel gave me some 5/8 5160 mud flap hangers, and I was making it out of that, and they were making some cool quality rail things. And yes, I did make some out of rail spikes, and they turned out pretty good.
Sounds like you're going to make some out of rebar there, right? Yeah, man, it's just to try it out.
Yeah, you know what? I actually don't have a lot of rebar. I have like a 2-foot section of 1.5-inch rebar, and like one section, like one maybe 4 or 5 foot section of 3/8 rebar. That's the only rebar I have. I mean, it's just not something that I have a lot of. And it's not for lack of looking, it's for a lack of need to look. As it was said before, most beginner blacksmiths, that's one of the first steels that they come across because it's so common and so thrown away. I happened to start with a collection of, random rusted steels that were, found in my backyard, not all of which was rebar, So I didn't really need to start with rebar. Roy in a kilt forging a knife. People want to see the kilt. Okay. But yeah, sinus is acting up. But yeah, so those early videos of mine with the rails, or with the oyster knives, could have been anything from mild steel to screwdriver handles, or screwdrivers, to coil spring. I'd have to look back at some of the early streams and find out. I'm assuming.
I thought it was rebar. So I mean, I just misremembered it. That's fine.
No, they were all twisted.
Roy, to quote Rob Garman, you thunk it, now you got to make it.
Yeah. Yeah, Roy is going to use a railroad spike for a hammer, while choking up on the handle, and he's going to forge a half knife, half toilet, or half spoon toilet knife combo out of rebar wearing a kilt. It's official. Tune in for his next live stream. That's what he's going to be forging in his bathroom, wearing a kilt, using a railroad spike as a hammer. You heard it here first. Go subscribe, like, share, and subscribe to Roy at Christ-Centered Ironworks. You're going to see some amazingly ridiculous stuff. If I can pass any knowledge on to Roy, it's embrace the ridiculous. You've given us all the knowledge, now embrace the ridiculousness. Even if it's a side video series.
Now, just to go back to Rebar, right, now, talking about videos and all that type of stuff, I have used a lot of Rebar, particularly for making tongs. I think my 100 subscriber giveaway was a pair of Rebar tongs that I sent to Canada, to one of my subscribers in Canada. And I've made a lot of tongs out of Rebar, out of half-inch Rebar. And I've broken some, but show me a blacksmith that hasn't broken a pair of tongs. Now, you know, these tongs were in and out of, you know, they get hot. I'd quench them. You know, I would, you know, I abuse these tools, you know, and sometimes the jaws would snap. Sometimes I chisel a bit. I'd make a set of wolf jaw tongs and I'd chisel a bit too deep, and over time it would fracture and weaken and bend and they'd snap. You know, that but again, that was a tool, and they were tools that lasted quite a long time. I believe I still have at least one set of Rebar tongs in my tong collection, you know. So, and that was half inch, you know, 12. I think I've got a set of 16 mil, or 20 mil tongs there as well, which are heavy as hell. But you know, those. So yeah, so you know, Wayne said that he's got a pair of my reinforcement bar tongs. So you know, at the end of the day, these are things that you can still practice on tool making. Tongs are a great thing because we all need them.
Yeah.
You know, and better than go and buy a new steel for tong making when you can pick up. You know, you can. And one of the things that I did when I first started was I would literally go to construction sites, particularly for house building and stuff like that, and ask them if they had any offcuts of reinforcement bar. They generally point me at the scrap metal bin and go for gold, just don't injure yourself, and I get it for free.
Sorry?
I want to just point out there, Adam. Wayne said he had a pair of those Rebar tongs. He didn't say has.
Good point. They could have broken by now. They were early editions.
I don't know if he's breaking out or what.
Me?
Who?
Yeah, I can't tell. There's so much going on in my head. I can't tell if you finished your statement, Adam, and stopped talking, or if you just cut out. But you coming in clear?
No,
It was good.
No?
It was good on my end. So.
I'm nice and loud and clear. And
Okay.
Can everyone on the chat hear me nice and easily?
Yeah,
You're coming through on the Discord.
Yeah.
Everybody's coming through on the Discord just fine. So.
Okay. It just, maybe you just finished your statement and like mentally I thought there was more. Okay, real quick off topic. I want to answer Bloobs here. Give him some help. He wants to know if there's an easy way to cut a washing machine drum with a cutoff grinder around the circumference of it, around the circle of it, for it to be even. Yeah, what you got to do. Well, okay. This isn't one of those, this is the only way to do it, but here's what I've seen work best and what I've done for cutting drums. Get it up even and level on a couple rollers or whatever, and set yourself a kind of a jig to hold a pen or pencil or Sharpie or whatever, and roll the drum so that it creates an even line down it, okay? And then just take your cutoff tool and cut down that line, follow that line specifically, and it should, that is definitely an instance where you want to draw a line so you don't stray. Sorry. And everybody's pushing for Roy to do a comedy series. And I think I've told him before, I think he should. Okay? Put it in a separate playlist and at every title be like, have parentheses, satire only or something. And just embrace the weird. You've got such knowledge that it would be hilarious to see you, be like, all right, today I'm going to be forging this loaf of bread and stick it in the fire, it burns.
Or can you use bread as forge fuel?
Yeah, stupid ridiculousness. I'm talking stupid ridiculousness. And I would love to see because you're a funny guy. Me and you have sat there and joked around a lot. You're a funny guy. And between your sense of humor, Jess's sense of humor, and the internet's sense of humor, I don't have time to make those kinds of videos, and I don't have the clout for it to be as funny as it would be if you were to do it. If I had, 1 million subscribers like you and was known for my knowledge, I could get away with that kind of satire. Coming from me, it would be like, oh, this YouTuber doesn't know what the heck he's talking about. The joke of it would be that a known, knowledgeable smith is doing the ridiculousness.
So, Yamath, I just want to jump in. Another way, I want to answer Bloobs as well. Another way to do that, cutting the drum, marking the drum, is to use a chalk line. And so if you particularly have a concrete base, and you can set up a chalk line, because that way you can move it up and down depending on the height you want, and then you can just put the drum up against it, give the chalk line a flick, turn the barrel, give it a flick, and that way the chalk line marks out depending on how high you want the cut to be as well. So that's another option, just in case you don't have access to rollers to mark it out.
Yeah, Roy brings up a good point. He's got so many people who threaten him with unsubscribing anytime he does something different on his channel. Okay, Roy, I think it's time for you to start a second channel. And I guarantee you.
Yeah, he's got time for that.
Huh? No, it would be the same amount of work. It's just be a different place to upload it. Kind of like Black Bear did, doing his Black Bear Forge shorts or whatever. I don't know.
Black Bear Forge and then John Switzer.
Yeah. But just have like Christ-centered Ironworks,
and then the Adam Family,
and then you have Adam's Family Comedy, or Blacksmithing. Just come up with a clever name, and you're awesome. But it's something that really only you can do, or either you and or all of us. Let's do this. I'll call John Switzer and be like, all right, me, you, and Roy are going to do a comedy series on blacksmithing of false.
And John's going to say, no.
Yeah, I know, right? He'll be like, I don't got time for that. But like a full-on comedy series of like wrong. Like, did he cut his grass, scoop out of the bag, put it in a jar, add freaking epoxy, and make a hammer out of grass? And then use it? Yeah. Stupid stuff. But anyway, man. With me doing everything I can to sidetrack the conversation, we just talked about nearly 2 hours about rebar.
Has that been 2 hours already? Jeez.
1 hour and 43 minutes. And here's the thing. I know that there is a lot more that can be going into it. So...
we didn't even broach the topic of stainless steel
or coated
reinforcement
rebar.
bar and the users of that and la la la.
Or coated
I've never even seen that.
Oh yeah, stainless steel rebar exists. So does coated rebar. You got galvanized. You got. I've seen copper coated rebar ground rods before.
Yep. You've got enamel and epoxy coated
enamel and epoxy coated.
rebar. You've got Yeah, fiberglass or fiber coated rebar, polymer coated rebar. It's all different types of rebar depending on the job and what it's for.
Yeah. Yeah, it's rebar is such an extensive. It's like you have steel, and then all the different types of steel. Then you've got rebar, and all the different types of rebar. You know, like it's not like rebar is a type of steel. Rebar is a type of shape, structure, whatever, made out of all these different types of steels and all these different types of rebar. Heck, I've seen plastic rebar.
Yep.
And yeah, I mean, like Roy was just saying, you know, like people giving him bad comments or whatever, or you know, about when he gets a little bit off of the path. Personally, like the last couple videos, the can you harden the Harbor Freight anvil, case harden or whatever, I found those absolutely fascinating.
Yeah.
I mean,
and you know, now, okay. From a,
I mean, I really did. I enjoyed them thoroughly, and I was like, I never even thought of that. I just welded a plate on mine, but you know.
Yeah,
I'm glad I didn't try to do that, but.
Yeah, he's 100% right though. Like, you know, he's got 1,700 videos out there. He just did a count, you know, recently. 1,700 some odd videos out there about forging. You know, and then every time he tries to break away and do something even slightly entertaining, like, you know, in the ridiculous aspect of quenching a freaking Harbor Freight anvil, like, it's needed for for conversations in beginner groups. It's absolutely a needed video. But then to get back to forging what? I'm done forged it all.
I know. I mean, like, I'm on 1,700 videos. Roy, do you ever just sit there and go, I have no idea what to do that I haven't done?
Oh, I'm sure he does. That's why he quenches Harbor Freight anvils. Hey, Holler. I have to step away and take a bathroom break right quick, guys. So I will leave you guys in the capable voices of.
Wait, you're not going to take the laptop with you? What's up with that?
No. I gotta go hike my skirts up.
That's not a visual I want to imagine. So if anyone's got any questions in the chat while Yames goes away and I try to scrub that thought out of my brain, please ask.
I'll be right back.
All right, Adam. How long you were in the used to be involved in the manufacturing of a reinforcement bar? How long did you do that for?
I was in that for 5 years. I started off as a general labourer in the workshop that I was in, and then worked my way up to what was called an off coil bending machine. So that was so we did so when in reinforcement manufacturing, of course, you've got the actual smelting and creation of the bar, which I looked into and everything when I worked there. We actually did the bending of the steel bar and the mesh that went into buildings. So if you ever seen construction go up, the reinforcement will go in first and they'll go through and either weld or wire different shapes together. So we would bend all the bar from 6mm, quarter of an inch right up to 50mm or 2 inch into shapes to make the actual structures go together. So the machine that I worked on was an Italian machine that used to take 16 or 5/8 no, not 5/8, 7/8 steel. No, a little bit less than that. 5/8 steel, and 12mm or ½ inch off a 2-ton coil, and straighten it out and bend it into different shapes to make basically whatever, either straight bar or complex 3D shapes to make the reinforcement that went into buildings and bridges and piers and all sorts of stuff. There's the entertainment centre in Darwin, which is the city that I live in Northern Australia, or city I live near. It was built about 10 odd years ago ish, and most of the steel that's in that either came from the workshop that I worked at or I made personally. So there's several hundred ton of steel in that I spent a long time bending, either on this machine or manually.
Right.
Hey, and I got Yamez moved out of the way, and I just started. I got this like nervous tick going on because is it just me or is that John Coffey hanging just a skosh crooked?
It might actually be my camera because, all right.
Well, I know I see the camera's kind of at an angle, but relative to the couch, it looks like your right side is lower than the left. I don't know.
Okay, so in order to, let me show you. Let me remove everything of the background. Okay, that's the full image. If you're watching that I have to have this entire space over here clear, so it's literally the angle the camera is looking. But if I were to put a level on it, and I have two nails holding it up, it's not just one.
Okay, fair enough.
Yeah, it's literally just the angle. So
It's that old perspective drawing.
While Adam was talking, I was staring at it going, man, I didn't notice that before.
Good old perspective drawing type thing. It's just the angle that everything is on.
yeah.
Right. Oh, okay, yeah. See, now the video caught up to what you were saying with it. And I see it now. Yeah.
Yeah. It's I have like it's so weird for me because, all right, this right here, from my perspective, is the very edge of it. The camera is actually pointed like straight over here. So I'm looking at the edge of the camera, the edge of the field of view of the camera, to keep me in frame for all the side stuff here. So, but yeah, Roy and I have actually chatted in the past, and I would still love to do this. It's just a matter of time and money. Discussed getting together and forging an anvil together. Now, I don't want to let too much information out in case it would be a surprise when we do it. But yeah, we have discussed something along those lines. It's just finding the time and getting together and doing it. Roy, if you remember what we talked about, I would still like to do that. It just may be a little bit more. I got to do it before you get too old and can't lift a hammer anymore.
You only got a year or two left. So
I know. He's younger than me. Shut up.
We know. That's why we said we've only got a year or two left.
Yeah, Roy's the baby of the group.
Yeah. Howdy, barf. But yeah. What a day. Like, I gotta say, now I just need to come up north. Now, in all seriousness, Roy, if you remember what I'm talking about, can I bring up the thoughts we had? Can I mention it as a upcoming future possibility, or an idea that me and you had, or would that be loosing a potential surprise, in the future? And but yeah, as for doing it, yeah, basically what I would need to do is I would need to take a few weeks off of work, get the steel. He's a sweet baby boy of only 33. You're such a baby. Pinches cheek. Yes, you are. But yeah, I would need to get the steel together for it, and Roy would have to build a specialized ground forge and all that fun stuff, and we'd have to basically build the working area for it and the tooling, and then get on it. I would have to take several weeks off. I think it would ruin the surprise. Take several weeks off and get up there and like camp out in Roy's backyard and do it. Now, not to go into it, but with crypto, that may happen sooner rather than later. You know, because things are going very well for me. Not like millionaire well, but, you know, I'm on my way.
Yeah, I was gonna say if you're gonna go camp in Roy's backyard, I don't know about that, Yamas, because even in July you're gonna be too cold. You're gonna be like, oh my gosh, it's 60 degrees out here. I didn't bring a jacket.
I can camp in 60 degrees. I've done it before. You know.
Okay, and sleeping in your pickup with the heater on doesn't count.
At that point, I may have a little RV I can drive around in.
Yeah, when you're in an RV, it's no longer called camping there, yeah, man, it's glamping.
Yeah, but the point of going up to Roy's would be less to camp and more to make this item we are discussing. And it may be a year or two, but it's going to happen. You know, and Roy may not even know when it's going to happen. I may show up and be like, all right, I got a couple months, let's get this out. I got a couple months before my private jet flies over to Australia. Let's go. Come on. But build the forge right next to his lake so we have a place to quench it. Yeah. But yeah, so absolutely, Paul. You know our winter is your summer. So cry more. And you know that
oh man,
Adam doesn't have to deal with that at all.
That just reminds me. It's like we're having opposite year down here in Texas. It's going to be 90 degrees today. It's like
yeah.
all week has been shorts and t-shirt weather. We had like 3 cold days the whole month, and the rest of it is just still hot and sweaty, still running the air conditioner.
And whereas
I got a message from Sam today, and he showed me that it was 44 degrees Celsius down in Perth today, or which is about 114 degrees Fahrenheit ish.
You guys
which is
have fun.
Ridiculously hot. That's how hot it was today.
Okay. Yeah, Boar. So that's a teaser of things to come in in the future with me and Roy. Like, the only thing keeping me and Roy from doing a lot more fun stuff together is the distance, and the money it costs to travel that distance and take time off for me to do that. Once all of that's no longer an issue and this show goes on the road, Roy's going to have to beat me with sticks to keep me away. He's going to put up a Yamez-proof fence.
That's not hard to do. All he's got to do is build it like 2 foot tall. You're not going to be able to figure out how to get across
it. Yeah. Crazy to think this year makes 15 years. Yeah, man. Roy's been forging since he was a toddler. Yeah, Trail Dust, you missed good stuff.
I'm just flabbergasted that Roy's younger than me. I thought he was at least a year or two older than me.
It's because this goofball has the wisdom of the ages, and he presents himself as a mature, responsible adult, and us immature, irresponsible adults all watch him and be like, and then we find out he's just a baby, and we're like, oh, what have I done with my life?
This is true. This is true.
The last 15 minutes of this is just going to be like, mess with Roy. Make the fence pirate themed. Right?
Instead of forging with Yamaz, it's messing with Roy.
Yeah, messing with Roy.
You just have to make the fence curved and tell you that the entrance was at the corner.
Yeah, I'll be like, I can't find it. I can't find it.
So we've had no when you went, we've had no more questions about Rebar. So I think everyone is quite satisfied.
Yeah,
which is interesting.
People are starting to wake up and ask me about things. So you can finish your thought. Fantastic topic. I'm
Thanks for holding off and let me join in on it. Consider it was.
As soon as you said that, I have maximum knowledge about this, I'm like, well, we're gonna wait. Because we want
say maximum knowledge, but I have a little bit. I have just enough knowledge to know just how much I don't know.
Yeah, I mean, come on, let's face it. We all know that down there in Darwin, you take and you reach into the ground and grab iron and ore, and you reach in and grab other stuff, and you go like this and go, and you make your own rebar. Well, we know this to be true.
But I will posit that your knowledge on rebar vehemently just dwarf anything I possibly could have come up with. I mean, just your practical experience alone was priceless. I do appreciate your insight in that, Adam.
Yes, absolutely. I absolutely thank you wholeheartedly for being here, being able to let us know, hey, might want to wait on that. I got some input, rather than us just go off half-cocked, so to speak.
Practical knowledge it can often be considerably more insightful than just
book knowledge. And that's what I tout all the time.
My train fell off the tracks as well. Like the last word escaped me.
You go, damn blacksmith stealing all the rail spikes. But yeah, so everybody, thank everybody in the comments. Everybody give Adam and Solbert a round of applause for coming up with the research behind the topics today. And I'd like to thank all of you in the comments for being here and participating. A lot of excellent input and discussion points. As always from me, thank you to my fellow hosts here. You guys are amazing individuals, and I always love having you guys here. I mean, Sully's my co-host. Let's face, like Sully is my ipso facto. He's the Hans to me being Chewie. I'm not the sidekick here. He's not the sidekick here.
No, you're right. You got it right. No. I'm the sidekick.
No, you're not the sidekick. If you're the sidekick, I'm the comedy genius, and you're the guy in the facts going, well, hold on. No, metal is hard. $10 super chat from Roy. This has been a great stream, folks. God bless you all, and Merry Christmas, Happy New Year, folks, or Happy New Year too. Take care. Take care, Roy. Thank you, man. Much appreciated.
Thanks for coming, Roy.
Yes. So yeah, I'm glad. I'm glad, and I hope, and I'm glad for those who have learned something here. Couldn't be here without you guys. So I'm gonna let you guys all get back to your Sundays. Any final thoughts, from the guests on the show?
Nah, man, I'm good. I just want to say I hope everybody had a Merry Christmas and have a Happy New Year coming up this next weekend, and don't do anything stupid. Be safe, and let's stick around and have another great year.
and from me, happy holidays to everyone. Happy Yule, have Merry Christmas, Happy Hanukkah, Happy Saturnalia, all the other ones. If hope you're having a great I believe it's Boxing Day there for you guys now. I don't know if you celebrate Boxing Day, but Boxing Day is the day after Christmas Day. For all your Aussies, it's now coming into the day after the day after Boxing Day. But if you're drinking, don't drive, stay home or stay wherever you are, and if you've got to get home, get someone else to drive you. Be safe and enjoy the lead up to New Year's.
Yeah, absolutely. That's why. See, all of that's why I just say Happy Holidays. It's not anything other than, like, enjoy the holiday that you celebrate, or not. If you don't celebrate holidays, don't enjoy it then. Whatever. Do what you want. So,
have a happy Sunday.
Yeah. You guys have a wonderful day. I'm going to go ahead and end this. And remember to share this information, link the video to comments, and shut up the naysayers. I'm entertaining, dang it. All right. Bye, guys. Peace.
Bye.
Bye.
And we're clear.